Problem number 12. The displacement of a wave traveling in the positive x direction is the displacement equal to 3.5 centimeters sine times quantity 2.7x minus 124t, where x is in meters and time is in seconds. What are the frequency, wavelength, and speed of this wave? So they give us the formula. d of x t is equal to 3.5 centimeters sine times 2.7x minus 124t. So we know the displacement formula, which is d of x is equal to a sine times kx minus wt plus the phase knot. So given this formula, we can figure out that the amplitude is equal to 3.5 centimeters, and the circular wave number, which is k, is equal to 2.7 radians per meter, and the angular frequency, which is w, is equal to 124 radians per second. They also give us the phase number, which is 0 in this situation. So what we're trying to find is the frequency, the wavelength, and the wave speed, which is v. For A, they ask you to find the frequency, and so the formula for the angular frequency is equal to W equals 2 pi times frequency. So we basically want to isolate the frequency, and so I'll isolate it by dividing the angular frequency by 2 pi. And so then we can just plug in the angular velocity, the angular frequency, and so it equal to F is equal to 124 radians per second over 2 pi. And you can calculate that out to equal to 19.7 hertz, which is the radians per second. So for B, we want to find the wavelength, which is equal to k is equal to 2 pi over lambda. And so we're going to isolate for lambda. So lambda is equal to 2 pi over k, which is the circular wave number. And we just plug that in. So 2 pi over 2.7 radians per meter. And that is going to equal to 2.33 meters. But we have to remember significant figures, which is 2 here. So it'll be 2.3 meters. For C, we want to find the speed of the wave, which is equal to v. So we can use distance equals rate times time in this situation, where lambda is equal to the distance, velocity, and then the period. So we know that the period is equal to the opposite of the frequency, so we can use that to solve for our equation. We want to find velocity in the situation, so velocity is equal to lambda over period. And since the period is equal to 1 over f, we can plug that in. So it's now equal to lambda times frequency. So now we have the answers for frequency, which is 2.3, or frequency, which is 19.7 hertz, and the wavelength, which is 2.3. So we can just straight up plug that in. So velocity is equal to 2.3 meters times 19.7 hertz. And so since hertz is radians per second, that'll be meters times per second. So the final answer will be 45.31 meters per second. There we go, and that's the wave speed.